Hello everyone, welcome to our channel Amazing World of Science, and I am Dr. Radha Subramaniam, your science teacher. So yesterday already we had started chapter 1 from class 10, chemical reactions and equations, and we learned so many concepts yesterday regarding what is meant by chemical equation, how do you write an equation, what is the importance of writing equations, and we were talking about unbalanced equations yesterday, and today I am going to continue with the remaining part of the chapter. Okay, now first we can start with this equation. See here, Fe plus H2O giving Fe3O4 plus H2. So what is Fe? Iron. Iron plus H2O. H2O is water giving iron oxide and hydrogen. So here you can see that the number of atoms on the left side is not same as those in the right side. For instance, see iron, left side there is only 1, but on the right side Fe3, 3 iron atoms are there. Okay, and oxygen on the left side only 1 atom, right side we have 4 atoms. So these are not equal, left side and right side number of atoms, since they are not same, we have got to balance the equations. So there are various steps on how to balance a chemical equation. This is the basic concept of chemistry. Without knowing how to balance an equation in higher classes you will be finding it very difficult. So just listen carefully, okay, we will do it one by one. So what is the first step to balance a chemical equation? You have to first draw boxes around each formula. See each Fe, draw one box, H2O, Fe3O4, H2. So around 4 formulas we have drawn 4 boxes, okay, but remember one thing, don't change anything inside the boxes while balancing the equation. So whatever formula is written inside the boxes, you should not change that. Now we will move on to the second step. List the number of atoms of various elements present in the unbalanced equation. Okay, so here what are the elements? Fe, H and O. We are having 3 elements, okay. Then number of atoms in the reactants, that is left side. How many of each other? Iron, there is 1. Hydrogen, 2 atoms. Oxygen, 1 atom on the left side. And number of atoms in product side, that is on the right hand side, okay. And iron is 3. Then hydrogen is 2. Oxygen is 4. Okay, now after listing the elements, we will move on to the third step. So often it is convenient to start balancing with a compound which contains maximum number of atoms, that can be a reactant or a product. So in that compound you select the element which has the maximum number of atoms. So using this we can select Fe3O4, that is the element oxygen has got maximum 4 electrons on the right hand side, and left hand side only 1 oxygen atom is there. Okay, now what we should do is first we will balance the oxygen atoms. So initially in the reactant side, see reactant side is this H2O, only 1 oxygen atom there, and in the product side in Fe3O4, see this is the product side, 4 oxygen atoms are there. So in order to balance it, what you have to do first, in the reactant side you multiply with 4, okay. Now to equalize the number of atoms, you remember that we cannot change the formula of the compounds or elements at all. See, to balance oxygen atoms we can put only the coefficient like this. See, before H2O you put 4. No, don't put H2O4. See, 4 cannot be put down here, or don't put like this. Okay. Now what we are going to do first, see here in the box, second box, see first, second, third and fourth box. So second box on the left side you put 4. This is the first thing we are doing, that is now partly this is balanced equation. Now iron and hydrogen are still not balanced. So any one of these elements you choose and you can balance it. Now what we will do? We will find out the try to equalize the number of hydrogen atoms. So hydrogen atoms on the left side, initially in the reactant side, see already we added 4 here now, isn't it? No, don't go to this equation, you look at this part. Here 4 into 2, 8 atoms are there for hydrogen, okay. So to balance 8 atom, and the product side how many hydrogen is there? Now only 2 is there, so it should be 8. So what you have to do? Multiply the right side. okay, with 4. So that what will you get now? 4 means you have to add 4 before H2, outside the box, before H2. So we did two things here. First we put one 4 before H2O, now we are putting another 4 before H2. See now what happens, number of hydrogen atoms, how many are there now? Hydrogen atoms on the left side, 4 2s are 8, right side also 4 2s are 8, okay. Now oxygen how much on the left side, reactant side 4, okay. This 4 is applicable to both hydrogen as well as oxygen. So this oxygen has got 4 atoms and right side also 4. Now here one more element is not balanced. What is it? Iron. See, iron left side has got only 1 atom, whereas on the right side it has got 3 atoms. Now what we will try to do is, we will try to balance iron, okay. So reactant side 1 atom is there, product side 3. So what we must do is multiply the reactant side with 3. See, 3 Fe plus 4 H2O giving Fe3O4 plus 4 H2. See, once finally you check the correctness of the balanced equation, once it is done, then you can write the full equation like 3 Fe plus 4 H2O giving Fe3O4 plus H2. See, each element, is it balanced? First iron, how many on the left side? 3. How many on the right side? 3. Hydrogen 4 2s are 8, here also 8. Then oxygen left side 4, right side also 4. Now the number of atoms of elements on both sides are equal. So the equation is now balanced. Now this method of balancing chemical equation is called hit and trial method, because we make trials to balance the equation by using the smallest whole number coefficient, and also writing symbols of physical states. Now you carefully examine this equation. From this equation, can you say anything about the physical state of each reactant and product? No information is given at all about the physical states. So we try to make the equation more informative. Then the physical states of the reactants and products should be mentioned along with their chemical formulae. So gaseous, liquid, aqueous, solid of reactants and products are represented by G gaseous, L liquid, Aq aqueous, and S solid states. So the word aqueous is written if the reactant or product is present as solution in water. Now what can we write? Iron is solid, so put S. Water is gaseous state, this is solid, and H2 is gas. Note that symbol G is used with H2O to show that in this reaction water is used in the form of steam. Remember this point, very important. Usually physical states are not included in chemical equation unless you need it to necessarily specify them. So such as in some reactions and all that, conditions like temperature, pressure, catalyst, etc. for the reaction are indicated above or below the arrow. See, in this equation CO plus H2, these two are gases. See, this is occurring at 340 atmospheric pressure. So we write an arrow, we write this above the arrow. And here also see, this reaction is taking place in the presence of sunlight and chlorophyll, photosynthesis, okay. So for that, those type of reaction you just indicate it either on top of the arrow or bottom of the arrow. Now after this, see, you have got few questions here. Why should the ribbon be clean before burning in air and all that. All these questions you can try to answer these questions on the basis of writing the equation, try to balance it and try to work out the exercise. And if it is anything difficult and all that, we will discuss at a later stage. So once this concept is over, now important concept we have to learn in our next session is types of chemical reaction. There are different types of chemical reactions which is very important for the examination point of view. We will learn it one by one. I hope today's concept of balancing the equation is clear for you. This is useful to all students and you have to learn to balance so many equations. Okay. With that we will be continuing the types of chemical reactions in our next session, and all of you please do like, share and subscribe to this channel. Amazing world of science. Okay. So with that I am concluding today's video. We will be uploading our next session at the earliest, and thanks for watching.